let's go down to this part right here. It says find the inverse of each function. We are doing examples off this page so that we can do some of your homework for you, but not do the fun ones. Okay. All right, so when we find the inverse, what's the first thing we do? You switch x and y. Okay, so I'm going to say x equals log base 3 of y plus 4. This is number 9 on the boring worksheet. Okay, so now our goal is to solve for y. So first we ask ourselves, is there anything we could add or subtract to the other side? Nope. Is there anything we could multiply or divide to the other side? Nope. So now we have to think about the exponent part, which for us is going to mean we have to get rid of the log and turn this into an exponential problem. Okay? So do you guys want to Tootsie Roll or do you want to do the inverse? Inverse. So the inverse of a log base 3 is a base of 3. So I'm going to base of 3, base of 3. The base of 3 and the log 3 cancel. So I get 3 to the x equals y plus 4. Now we can minus 4. 3 to the x minus 4 equals y. What do I do to make sure the notation is correct? Little negative 1 inverse, and I'm done. All right, let's try number 10. All right, so before we do any math, what should I do first? Switch the x and the y. Okay. Is there anything I could add or subtract to the other side? 5. What do I have to do with it? Subtract. So x minus 5 equals negative 2 times 4 to the y plus 1. Is there anything I could multiply or divide to the other side? Divide by negative 2. X minus 5 divided by negative 2 equals 4 to the y plus 1. Most people would not leave that negative on the bottom. So what should I do with it? I'm going to move it to the top, and what happens when I move it to the top? It'll be negative x plus 5. Okay, so I'm just going to write that up here. Now, if you did not do that on a test, you are still right. But if you're doing a multiple choice problem, I want you to be able to find your answer. Okay? So next we have to look at exponents, and our variable is stuck in our exponent. So how do we undo exponential form? We log. All right, what base does the log need to have? A 4. So I'm going to log base 4, log base 4. The log base 4 and the base of 4 cancel. And we have log base 4 of all that stuff equals y plus 1. And then what do we do? Subtract 1. Log base 4 of the stuff with a minus 1 on the end equals y. And what do I do before I say I'm done? Little inverse. Okay, the next two look pretty simple. Let's look on the back. Which one looks like bleh on the back? Number 15? Okay. So what do we do first? We switch x and y. Okay. So what do I do? Subtract 1. So first step is to see if there's anything we could add or subtract to the other side. We're going to subtract the 1. So x minus 1 equals 3 log base 6 of y minus 2. What do we do next? Divide by 3. So our second step is to see if there's anything we could multiply or divide to the other side. So I'm going to have x minus 1 divided by 3 equals log base 6 of y minus 2. Now I have to get inside of something that's protected by a log. How do I do that? Yep, make it into an exponential problem. So I'm going to undo the log base 6 by putting in base 6. 6, 6, look at that crazy exponent on the 6. So we have 6 to lots of stuff equals y minus 2. It's a lot of exponents. And then we're going to add the 2. So 6 to all the things plus 2 equals y. And before I box it, I put a little inverse. Yeah. Yeah, why is it scary? Okay, let's rewrite it. So I'm going to say, before I trade the x and the y, I'm just going to make it into a friendlier format, okay? I'm going to say y equals 9. Instead of ln, what could I write that would maybe be more student-friendly? Log base e. And then this 2x's together, I'm going to go ahead and put parentheses around that because it doesn't need the parentheses because they're already grouped, but sometimes the parentheses help us keep track of what we need to do. Okay, is that better now? I think we could do that on our own. You think we could do that on our own? Okay. All right, are there any other ones that you look at and you're like, ooh, that's scary? Ooh. Yeah, I think 18's okay. Number 14. If there were parentheses, there's a reason they didn't put them. But if you wanted to put the parentheses, where would they have to be? Around the x only. That's the only place you can put them where it wouldn't matter if you wrote them or not. And they did not write them, which means it didn't matter. Okay, so this is log base 3 of x. The plus 2 is on the end. Okay, does that make sense? All right, now we can go to the build a monster activity. This is how it works. You do the problem, here's the problem, and then you have multiple choice answers, and the answer tells you what to draw. So you're all going to have the same monster, but that's what makes it fun, is because you know what the monster is supposed to look like one thing, and your different variations of the same monster are going to be like top notch, let me tell you. They're going to be real good, okay? So the first problem, the answer of the problem tells you what feet to draw. The next problem tells you what hair to draw. The next problem tells you what eyes to draw. When you flip the page, it will start to tell you what color to draw. All right? Yes. So your monster, here's the body of your monster. That's the other page. There's the body of your monster. All right? So this is the body. So when you draw the feet, you're going to draw them down here, right? He's like a big fuzzy body, and his feet are going to come down here. Okay? Make sense how it works? Yes, Ms. Rice? Marvelous. All right, go ahead and get started. You do not have a video over the weekend because we had a quiz on Monday.